Welcome back. So now what we're going to do after we learned all those notes and concepts, what we're going to do is now we're going to apply them. So let's start with the first topic of the day, example 1. And so example 1, the directions say that show that the functions are inverses. So this is like when you read directions, it's really important what it says. Since it says show that the functions are inverses, what does that mean? That means these two are inverses and we just have to show it. And if it comes out wrong, like if they both don't equal, if they don't both satisfy the property, the inverse property that they both equal x, something went wrong. All right, so let's go ahead and do this. So I have the steps right here. Determining, so what you do, so it's essentially just using the inverse property. When you want to use it, if you're determining if they're inverses of each other, you have to find the composition f of g of x, and then you have to find g of, and then this is supposed to be f, sorry, g of f of x, right? And then we have to see if they're both x's, right? So let's start with f of g of x. So when I see it look like this, what does this tell me? This is f of g of x. Okay, so what do we do here? So g of x, we know, is x minus 4 over 5. Okay, and now what am I going to do with this? Wherever I see an x, I'm going to plug it in. I'm going to plug this in. So I have 5, and then x minus 4 over 5 plus 4. Okay, so these two, they're both factors, so we're multiplying, so they can reduce to 1, so then I'll get left with x minus 4 plus 4, and then I'm left with x, right? We're not done. Just because one of them equals x doesn't mean that the other will equal x, right? So now we have to do g of f of x. Okay, when I have g of f of x, what does that tell me? This is g of f of x. And I know what f of x is. F of x is 5x plus 4. And wherever I see an x, I'm going to plug in the 5x plus 4 into our g function. So I have 5x plus 4, then minus 4 over 5. Okay, I can just drop these parentheses so they have a 1 in front of them. So even if I distributed that 1, it's the same thing. Right. So in the numerator, I have if I combine like terms, I have 4 minus 4, that's 0. So I'm just left with 5x over 5, and this is equal to x. Right? And what does the property tell us? The property tells us that if they both equal x, right, and then it's in the domain of g and f. So in this case, since this is a polynomial, the domain is all real numbers, so our domain is negative infinity to infinity. So is the range. Range is also negative infinity to infinity. And then over here are fractions. So what is our only restriction on the fractions? It's that our denominator can't equal 0. But can 5 ever equal 0? No. So what does that mean? Its domain is also negative infinity to infinity. And so is the range. Right? So because they also satisfy it in that way, what does that mean? F and G are inverses of each other. Oh my goodness. All right. So now, since there's some space, and now let's do example 2. Okay, so example 2, our instructions are a little different. Example 2, it says for each pair of functions f and g below, find f of g of x and g of f of x. Then determine whether f and g are inverses of each other. Right? So example 2, we're given f of x is equal to 3x minus 1, and then we're given g of x, which is equal to 3x plus 1. Right? So our first instruction, so essentially this is A. A, we want to find f of g of x. So when I see f of g of x, my mind immediately goes, I need to write this as f of g of x. Okay. I know what g of x is. G of x is 3x plus 1. And now wherever I see an x here, I'm going to, in my f function, I'm going to plug in 3x plus 1. So this is 3 and 3x plus 1 minus 1. Right? So first of all, we have to distribute. Right? So then I get 9x plus 3 minus 1. And this is 9x plus 2. Right? So if we get here, if we didn't have the instruction to find g of f of x, we can immediately answer part C. So essentially, I'm calling this A, this is B, and then this is C, right? But from A, from what I know, since this does not, what happened? Okay, this does not equal x. Okay, since it doesn't equal x, we can automatically say f and g are not inverses of each other, right? So if you were just given determine if these two functions are inverses of each other, you can find one, and if it equals something other than x, you can just automatically say f and g are not inverses of each other. However, if f of g of x did equal x, you still have to find g of f of x, because g of f of x might not equal x, right? But in our case, so that's C. In our case, our instructions are different. We still have to find g of f of x. So let's go over here to the side. So g of f of x. When I see that, this in my head, I say, okay, g of f of x has to be rewritten like that. I know what f of x is. F of x is 3x minus 1, so we're going to substitute that in. Okay, so then I have 3 and then 3x minus 1 plus 1. Again, let's distribute, so this becomes 9x minus 3 plus 1. This is 9x minus 2. Okay, so this is what g of f of x is. This is what f of g of x is, right? They both do not equal x, so therefore for C, they are not inverses of each other. One last thing I want to say about this. So if you did determine like 9x plus 2, and then like if your directions were determined if they're inverses of each other, and you do go ahead and find g of f of x, right, and then you come to the conclusion, that's perfectly fine, right? I'm just trying to help you guys out, trying to make you do less work essentially. If like you don't have to do it, but if you want to, or if you like really want to make sure, then go ahead, right? But I'm just telling you guys, if the question is determine if they're inverses of each other, and you do this and you see it doesn't equal x, you can just say they are not inverses of each other, right? So that's the end of the first topic, and then we'll go on to the second topic after this.